Alright, so assignment number 7, I'm combining number 3 and number 4 together. Both these problems are looking at the domain of they're looking at whether on number 3 the graph is a function, and number 4 is asking about the domain of a function. To give you a little bit of background, we talk about a function. The word function in math refers to the inputs and the outputs, or the x values, which are your inputs, and y values, which are outputs. The function means the formal definition is for every input or x value there is only one output or y value. So something like this. If I gave you a table of values and said on this side of my x's, on this side of my y's. Well, if I made up numbers like 3, 4, 5, and I had a 7 over here, 8, and a 9. Well, if I ask you if this is a function, for every input I look at x values, there's only one output. So if I have a 3, it only goes to a 7. If I have a 4, it only goes to an 8. 5 only goes to 9. So yes, this is a function. No x values are repeating. Essentially, that's what you're looking for. So 3, 4, 5, 6, 4. 8, 9, 10, 11, 12. Okay, so if I ask you, is this table a function? Well, there's a 3 here that matches with the 8, 4 matches with the 9, 5 matches with the 10, 6 matches with the 11, 4 matches with 12. This should be a red flag to you. Because there are repeats 4 here, this means 4 is getting matched up to the 9, and then later it's also matching up again with the 12. To my students, I typically say, and it's easy for them to remember, look at the repeats. This means the number is going out on a date with more than one person. So it's not a function because there's cheating going on. So we just talked about, say, is this a function? They look at the x values and say, no, 4 is repeating, it's cheating, it's dating a 9 and a 12 at the same time. This is not a function. There's cheating going on. Now, when we look at graphs, something like this, if I put a line like this, well, this time I'm not giving you all the numbers for the x values because we'd be here forever, because this graph, looking at the arrows, goes on and on. But what you are looking for is saying, okay, here's your x-axis. Well, this only matches up with this point. So it only has one partner. This point has a partner here. This part has a partner here. So every x value that I'm picking down here so far, when I go up to the graph, it only has one partner that's actually on the line. Now, these graphs can also be under, so if I have an x value here, I could go down and hit the graph once there. So yes, this is a function, because every time I pick an x value and I draw it to the graph, I'm only hitting it once. Something like this, if I would kind of make a little, meant to be that in a different color, oh well. Even if I pick all on here, I go up here, I only hit once, hit once, hit once, hit once, hit once. And if you notice all these lines that I'm drawing, these are vertical lines. And I say, is this a function? Yes. It doesn't touch the graph any more point. Each line we're looking for to see if it passes the graph one time or more than one. If it only passes one time, it means it's matched up like this, 1x, 1y, 1x, 1y. Now if I would have a graph like this, and draw it somewhat like this, if I take this x value way up here and draw it up, it's past touching only once more. And if I draw it down, it's not hitting it. But if I were to move it over and say I pick this x value, if I draw it up, it hits there. But I also need to draw this down. It's hitting excuse me, 3 different y values. So this x is dating a y up there, a y there, and a y there. All of a sudden, this is a red flag to me because this is happening at many other points, and this tells me to stop looking at this. This is not a function. And the reason being is, what they call it is the vertical line test. This fails the vertical line test. The vertical lines are the things I've been drawing up or down to make sure that they only hit the graph once. This one up here is a function because it passes the vertical line test. So does the other one that passes the vertical line test. Vertical line test is making sure any perfectly straight up and down line only would hit the graph one time. If it goes through more than one time, it fails the vertical line test. Now for number 4, the domain. Domains for functions, for problems, are very particular when you have fractions. Now the only thing you have to worry about in a fraction is the denominator, the bottom part. This cannot equal 0. So, if you have a variable down here, we got to figure this out. So the first thing I'm going to do, just so it looks a little bit more like we're used to seeing, I'm going to change this to a y value. Remember, just like we did numbers 1 and 2. This is a fancy notation in math for just y. So it's y equals, and I'm going to write the other side, y equals 2x plus 10. I don't care what's on top. I don't care whatever I have, variable, exponents, anything. I just don't ever want the bottom to be 0. You can never divide by a 0. So what I'm going to do is take the denominator and figure out when is this going to be a 0. So if I subtract 10, I get 2x. I don't want it to be negative 10 divided by 2. X cannot be negative 5. So this slash to the equal sign means it cannot be. So X can be all or any real number except negative 5. So all real numbers except negative 5. So this means if I pick negative 4, negative 3, negative 2, negative 1, all that decimals are good. However, if I pick negative 5 and plugged it in, it tells me I'm going to have a 0 on the bottom, which you can't do. So just to give you a quick other one like this, if you had x on top and then negative 3x plus 6 on the bottom, same sort of thing. The only thing you're worried about is this bottom part. I don't want the bottom to ever be 0. I don't care what's on the top. If there's a variable, I'm just going to leave it alone. So I set my bottom. I don't want it to be 0. I'm going to figure out when that happens. X equals positive 2. So this function can be, x can be any real number except it cannot be positive 2. That will cause a problem.